We now proceed with part 3 of the discussion on parametric surfaces. Here are the exercises or examples for this part. If you want to try answering the exercises first, you may pause. If you want to see the solutions, you may continue playing. We now discuss the first item. Kung medyo mahina, pwedeng pakilakas ng konti yung volume. First example, find a set of parametric equations for the surface 2x squared plus y minus 3z equals 0. Let x equals u and y equals v. Later on, i-express natin yung z in terms of u and v. Using the equation of the surface, we express z in terms of x and y. So we have 2x squared plus y equals 3z. And dividing both sides by 3, we get z equals 2/3 x squared plus 1/3 y. Since x equals u and y equals v, we get z equals 2/3 u squared plus 1/3 v. Hence, a set of parametric equations for the surface. Gagamitin natin itong mga equations na to. Tapos ito. So we have x equals u, y equals v, and z equals 2/3 u squared plus 1/3 v. Alternative solution. Instead of x equals u and y equals v, we can let x equals u and z equals v. Dito naman, we express y in terms of u and v. So using the equation of the surface, we get y equals negative 2x squared plus 3z. Since x equals u and z equals v, then y equals negative 2u squared plus 3v. So, a set of parametric equations for the surface, gagamitin natin yung equations na to. Tapos ito. X equals u, y equals negative 2u squared plus 3v, z equals v. So we're done with this example. We now proceed to the next item. Find a set of parametric equations for the portion of the sphere x squared plus y squared plus z squared equals 1, where z is greater than or equal to 0. Let x equals u and y equals v. So we express z in terms of u and v. From the equation of the surface, we get z squared equals 1 minus x squared minus y squared. Pag na-express natin yung z in terms of x and y, we get z equals plus or minus square root nito. But since z is greater than or equal to 0, we get z equals square root of 1 minus x squared minus y squared. Ito yung plus square root dun sa plus or minus square root. But since x equals u and y equals v, then z equals square root of 1 minus u squared minus v squared. So we now set parametric equations for the surface using this and this equation. x equals u, y equals v, z equals square root of 1 minus u squared minus v squared. We're done with this item. We proceed to the next. Dun sa previous example, yung pinarameterize natin is a portion of the sphere where z is greater than or equal to 0. This time, we will parameterize the entire sphere. Hindi na natin pwedeng gamitin yung technique na ginamit dun sa previous example since we now have z equals plus or minus square root of 1 minus x squared minus y squared. Since z can be positive and z can be negative also. So what we do here is we let z equals u. From the equation of the surface, we get x squared plus y squared equals 1 minus z squared. Since z equals u, we get x squared plus y squared equals 1 minus u squared. Observe that x squared plus y squared is greater than or equal to 0 since yung x squared saka yung y squared hindi pwedeng mag-negative. So that 1 minus u squared is greater than or equal to 0. Bakit natin sinabi to? Since later on, magkakaroon tayo dito na square root of 1 minus u squared. Since 1 minus u squared is greater than or equal to 0, yung square root ng 1 minus u squared is a real number. So we can have this equation. Yung right hand side, ginawa natin ganito. We now let x equals square root of 1 minus u squared cosine v and y equals square root of 1 minus u squared sine v. I-check natin kung isa-satisfy nito at saka nito yung equation nito. So we express x squared plus y squared in terms of u and v. So x squared plus y squared equals square nito plus square nito. So we have this one. Factor out yung square ng square root of 1 minus u squared, we get this one. But cosine squared v plus sine squared v equals 1. And this expression here is equal to 1 minus u squared. So, 1 minus u squared lang itong buong to. We have this is equal to this. So, consistent siya with this equation. That means we can use these equations to parameterize the surface. And we now get parametric equations using this equation and these two equations. Hence, a set of parametric equations for the surface is x equals square root of 1 minus u squared cosine v, y equals square root of 1 minus u squared sine v, z equals u. Some remark, the portion of the sphere x squared plus y squared plus z squared equals 1, where z is greater than or equal to 0 can also be parameterized using these equations. Pero yung u is from 0 to 1. U is greater than or equal to 0 since z equals u and z is greater than or equal to 0 sa part na to. And u is less than or equal to 1 para maging greater than or equal to 0 yung 1 minus u squared. For this example, meron tayong alternate solution. Here, we let z equals cosine u. From the equation of the surface, we get x squared plus y squared equals 1 minus z squared. Since z equals cosine u, we have x squared plus y squared equals 1 minus cosine squared u. But 1 minus cosine squared u equal to sa sine squared u. So we have this equation. We now let x equal sine u cosine v and y equals sine u sine v. I-check natin kung itong nilet natin ay isa-satisfy nila tong equation na to. So we express x squared plus y squared in terms of u and v. Then, x squared plus y squared saan to equal square nito plus square nito, which is equal to this expression. Factoring out sine squared u, we get this one. But cosine squared v plus sine squared v equals 1. So x squared plus y squared equals sine squared u. Consistent ito doon sa equation na to. So we are now ready to parameterize the surface using this equation and these two equations here. Hence, a set of parametric equations will be x equals sine u cosine v, y equals sine u sine v, and z equals cosine u. Some remark the portion of the sphere x squared plus y squared plus z squared equals 1, where z is greater than or equal to 0 can also be parameterized using these equations. Pero yung u is from negative pi over 2 to pi over 2. Kasi yung z is greater than or equal to 0 sa part na to, so dapat cosine of u is greater than or equal to 0, and cosine of an angle is positive if the angle is in the fourth quadrant or the first quadrant na covered ng interval na to. We are done with this example. We now go to the next. Find a set of parametric equations for the portion of the elliptic cylinder y squared plus 4z squared equals 9 that extends between the planes x equals 3 and x equals 7. Here we let x equals u. Observe that 4z squared is the square of 2z. So from the equation of the surface, we get y squared plus the square of 2z equals 9. We now let y equals 3 cosine v. Gusto natin 2z equals 3 sine v. So that z equals 3 halves sine v. We check that these two equations here satisfy itong equation na to. Then, y squared plus the square of 2z is equal to this expression. 3 cosine v quantity squared is 9 cosine squared v. And this part is 3 sine v na naka-square, so 9 sine squared v. Factoring out 9, we get this. And since cosine squared v plus sine squared v equals 1, then y squared plus the square of 2z is equal to 9. Na consistent dito sa equation na to. So pwedeng gamitin tong equations na to for our parameterization. So we are now ready to give the parametric equations for the surface. We use this and these two equations here. Hence, the surface can be parameterized by x equals u, y equals 3 cosine v, and z equals 3 halves sine v. Pero, i-restrict natin yung u from 3 to 7. Since x equals u and we consider the portion of the surface, between the planes x equals 3 and x equals 7. So that ends this example and part 3 of the discussion. If you have any questions, you may ask your teacher. Meron pang part 4 yung discussion on the next video.